So in this video, we're going to begin by reviewing the exponent property of the log function, which we used previously in Chapter 7. You'll see shortly why we need to review this. So the exponent property of the log function says that if we have the log of y to the xth power, then that equals x times the log of y. So just as a quick review, we can use this to solve equations of the form 4 raised to the x power equals 75. So if we want to solve this, we can begin by taking the log of both sides of the equation. So if 4 raised to the x power equals 75, then the log of 4 to the x power is equal to the log of 75. And I'm going to put those in parentheses. So if I have the log of 4 to the x power, then by this property, I can bring the x in front of the logarithm. So that would be saying x times the log of 4 is equal to the log of 75. Now, if you'll remember, the log of 4 is just a weird number, and the log of 75 is just another weird number. So I have x times a weird number equals another weird number. So to solve for x, I'm just going to divide both sides by this number, log of 4. So if I do that, then x is going to equal the log of 75 divided by the log of 4. And we can do that on our calculators. So if I do the log of 75 divided by the log of 4, that is equal to 3.1144 approximately. So this is approximately equal to 3.1144. So in other words, if I take 4 and raise it to the 3.1144 power, that should be approximately equal to 75. And so we could check that. 4 raised to the 3.1144 is approximately 75. It's 74.999, which is approximately 75. So we can use logarithms to solve equations when we have the variable as an exponent. And so we're going to see that we're going to need to do that in the next example. So if I bring in our next example, Johanna paid $1,050 for a bond with a face value of $2,500. If the bond yields 6.6% compounded monthly, how long must she hold it until it reaches its full face value? So in other words, Johanna has paid $1,050 for this bond that's going to be worth $2,500 sometime in the future. And the bond's paying 6.6% compounded monthly. So our question is, how long is it going to take for this bond to reach its full value of $2,500? So in other words, we're looking for T. How long is it going to take? How many years? Well, in order to determine this, we're going to use our compound interest formula. So let's write that down again. A equals P times 1 plus R divided by M raised to the n power, where n is m times t. So I can fill in what I know. I know that Johanna paid $1,050. So that is the principal, is $1,050. And I know it's going to be worth in the future $2,500, so that is the A. We know that the interest rate is 6.6%, which will be 0.066. We know we're compounding monthly, so M equals 12. And so then N is going to equal 12 times T. So what we need to figure out is what's T. Well, if I fill in this information in my formula, I can then solve for T. So A is 2,500. So 2,500 is equal to P, 1,050. Both of those are in dollars, but the dollar signs will divide out. we have 1 plus 6% or 6.6% interest, so 1 plus 0.066 divided by 12. Again, we're compounding monthly, and that is going to be raised to the 12 times t power, because n equals 12 times t. 12 times, and we don't know what t is, so we don't really know exactly how many times it's going to be compounded. So if I clean this up just a little bit, the 0.066 divided by 12 inside the parentheses is 0.0055. So this right here is 0.0055, and if I add 1 to that, then it's going to be 1.0055. So I have 2,500 equals 1,050 times 1.0055 raised to the 12t power. And again, that 1.0055 is what I get when I take 0.066 divided by 12 and then add the 1 to it. So if I want to solve for t, t's up there in the exponent, so I'm going to have to use logarithms for that. So the first thing that I have to do is get rid of this 1,050. So I'm going to divide both sides by 1,050. So if I take 2,500 divided by 1,050, that is 2.380952381. So 2.380952381 rather. And that equals 1.0055 raised to the 12t power. So again, I need to get that t down out of the exponent, and so the way I can do that is by using the logs. So the log of 2.380952381 is going to equal the log of 1.0055 raised to the 12t power. And by our log property, we can pull that exponent down. So I'm going to have the log of 2.380952381. I'm not rounding that, because if we round and then do more calculations with it, our answer will be off because of rounding error. So that's why I'm not doing that. That's going to equal 12t times the log of 1.0055. So if I want to solve for t, then I can divide both sides by 12 and the log of 1.0055. Remember that log of 1.0055 is just this weird number, and so it's 12 times this weird number, and I'm going to divide both sides by that. So divide both sides by 12 times the log of 1.0055. So on the right-hand side, the 12s will divide out, the logs will divide out, I'll be just left with t. And so I've just got to figure out what this is. So I'm going to take the log of 2.380952381, close the parenthesis on that log, and I'm going to divide that by 12 times the log of 1.0055. Now again, that's a weird number, and I got to put that whole weird number in parentheses. So 12 times the log of 1.0055, close the log parenthesis, close the parenthesis that started there in front of the 12, and that is 13.18. So it's going to take approximately 13.18 years. So again, 13.18 years in order for this bond to reach its full face value of $2,500. So the answer, if Johanna keeps her investment for 13.18 years, then her $1,050 bond will grow and be worth the face value of $2,500. One last question for this section. Look at example 11. Sam and Betty would like to invest $10,000 in a bond. what annual interest rate compounded quarterly will be needed if they want the investment to grow to $12,500 in 5 years. So this problem's very similar to the previous one, except in this case, the question is, what's the annual interest rate? So in this case, we've got to figure out what's the rate. So we know that Sam and Betty are going to invest $10,000. That's the principal. And they want it to be worth $12,500 in the future. So A is the future value, $12,500. They're leaving it for 5 years, so that's the time. It's compounded quarterly, so M is equal to 4. And so that means N is going to equal 4 times 5, which is going to be 20. So there's going to be 20 different computations that's going to be done. Our question is, what's the rate? So using our formula, A equals P times 1 plus R over M raised to the N power. So we have 12,500, that's what A is. That equals 10,000, that's what P is. Both of these are dollars, but the dollar signs will divide out. Times 1 plus R, we don't know what that is, divided by 4 raised to the 20th power. So I need to figure out what R is. So to solve for R, I'm going to start by dividing both sides by the $10,000. So again, when I divide by 10,000, the dollars goes away. If you take 12,500 divided by 10,000, that's going to be 1.25. Again, the dollar signs divide out, and that's going to equal 1 plus R divided by 4 raised to the 20th power. Now this is different from our previous problem in example 10, because in our previous problem we had the variable in the exponent. This time the variable R is not the exponent, it's inside the parentheses here. But I need to get rid of that 20. So to get rid of that 20, I'm going to have to do the 20th root. So I'm going to take the 20th root of both sides of this equation. So if I do that, I'm going to get the 20th root and the 20th power cancel out. I'm going to have 1 plus R divided by 4 equals the 20th root of 1.25. Now you may remember from the previous chapter that doing the 20th root is the same as raising to the 1/20th power. So if I take 1.25 and raise it to the 1 divided by 20 power, that will give me what the 20th root of 1.25 is. So I'm going to use my calculator for that. 1.25 raised to the 1 divided by 20 power. And so that is 1.011219651. Again, I don't really want to round that because that would introduce rounding error. So 1.012199651. And that equals 1 plus R divided by 4. So to solve for R, I'm going to subtract 1 from both sides. So that's going to give me R divided by 4 on the right-hand side. And 1 point all of that junk minus 1 is just going to be 0 point all of that junk. So 0.011219651. So now all I have is R divided by 4 equals that. So to solve for R, I can multiply both sides by 4. So on the right-hand side, R divided by 4 times 4 is just R. On the left-hand side, I have 4 times that number. So if I take 4 times 0.011219651, that is 0.0448786. So that is 0.044878604. So that's our interest rate. Generally, we should write that as a percent. So that would be 4.487864%. would be the interest rate, and typically we're going to round that probably like to the tenths place. So that would be like about 4.5%. Again, we don't want to round until our final answer, but then we'll round to whatever place we need to round to. So Sam and Betty's going to need to have an interest rate of about 4.5% in order for their $10,000 to grow to be $12,500 in 5 years. So that concludes this video, and you should be able to do the Section 8.2 homework.